Let's begin. Today is September 6th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 5, 12, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A will look at our middle digit, the square digit, and compare it to the number 3. So should square be less than 3? Should it be equal to 3? Or should square be greater than 3? Criteria card B looks at our first digit, the triangle digit, and will let us know whether it's an even digit or an odd digit. Criteria card C will look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will look at our 3 digits, triangle, square, and circle, add them up, and will let us know whether the sum is an even quantity or an odd quantity. Criteria card E will look at the first 2 digits, triangle and square, add them up, and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should it be greater than 6? And finally, criteria card F will look at our 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, it can tell us whether it has no repetitions, as in the example 1, 2, 5, or it could let us know that it's a double number where there's a repeating digit, as in the example 1, 1, 2, or it could let us know that it's a triple number where it's a single digit repeated 3 times, as in the example 2, 2, 2. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card B. Okay, so the Turing Machine does not approve of my choice for triangle. I did choose an odd 3. Since it disapproves of it being an odd, it's letting me know that triangle is actually even. So let's go ahead and type that up in our notes for section B. And that again is that triangle is an even digit. And since it is even, that means I can cross out all of the odds. So cross out 1, 3, and 5. The next thing I think I want to test is criteria card F. Okay, so in this case, the Turing Machine does approve of my proposal. Notice that we're talking about, the structure, so to speak, again. And my proposal of 314 has all unique digits, no repetitions, and the Turing Machine approves of that. So in fact, our solution should not have any repeating digits. So let's go ahead and type that up in our notes for section F, and that's that the solution has no repetitions. Okay, so again, what that means is that all of our digits are unique. So we do have an even in triangle. We could still have an even for square or circle. We just don't know. Well, let's take a look at the next thing is criteria card D. Okay, so in this case, the Turing Machine does not approve of the proposal. Notice that for criteria card D, we are adding up all the digits. So let's go ahead and do that. So if we add up 3 and 1, that's 4. 4 plus 4 is 8. 8 is an even quantity, but again, the Turing Machine does not approve of that. So it's telling us that the sum total of the 3 digits should be odd. So let's go ahead and type that up in our notes for section D. And that again is that triangle plus square plus circle should be odd. Okay, and well, let's kind of review. So again, we do know that triangle is even. If I want an overall odd quantity or odd sum among the three digits, that means that yes, one of the other digits, square or circle, must be even. The reason is that if you add an even to another even, well, yeah, that sum is even, but then you need to add an odd to the mix. So yeah, so we're going to split triangle and square, one being even, one being odd. Now we don't have enough information to determine which one is which, but yeah, that's basically going to be the structure. So it's either going to be even, even, odd, or even, odd, even, something to that structure. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A that compares square to the number 3. We also did not test triangle and circle, the comparison of triangle and circle in criteria card C. And then finally, we also did not test the sum of the first 2 digits. So one common thing I've noticed from previous puzzles is if I do have an even among triangle or square, sometimes that sum could be equal to 6, which means that we're going to have a 2, 4, 4, 2 kind of solution to the first 2 digits. And obviously it's helpful because square can help us determine, well, which one is it? Square could be either 2 or 4. And then obviously triangle would be the other even. And then I guess we could use criteria card C. Once we know what even it is, we could figure out what odd circle might be. At least that's kind of my current supposition of how to approach this problem. So, you know, it's a 50-50, perhaps maybe the square, but also how would we pick circle? So for example, if it's 2, 4 for triangle and square, it could be that circle is going to be less than triangle, forcing it to be a 1. But if it's the other case where it's say 4, 2 for triangle and square, it could be that circle is greater than triangle, forcing it to be a 5. So yeah, so we're at least again, you know, as constructing a second round proposal, it could be something like 2, 4, 1 or 4, 2, 5. And you know, again, and that's only if the sum of the first 2 digits is 6. If not, then I think it would be true that square would be odd, and then circle would be the other even. That's plausible too. But let's go ahead and do 4, 2, 5. Let's see if that's correct or not. Okay, so we start off with this idea for this proposal based on criteria card E. So let's go ahead and test E. Okay, so the sum is not 6. Okay, so that's very informative. So let's just type it up, and again, that was for section or criteria card E. So let's go type that up, and all we can say is really that triangle plus square is either less than or greater than 6. Okay, so we know it's not exactly 6. So what I meant by that's very informative is since it's not equal to 6, that really is well, let's see, yeah, well, we do have unique digits, so we know it can't be like a 2, 2, or a 4, 4. So yeah, so in fact, we know square cannot be even. So it's actually odd. So let's go ahead and cross out the 2s and 4s. Okay. And so yeah, so that's odd. So let's see. We can still compare. Yeah, we can still obviously, yeah, let's go ahead and test criteria card A and see what we get. Okay, so that's also incorrect. So let's see. So that just means that since I chose 2, which is less than 3, that's not true. So we had already crossed out the 2 anyway. So it just means that it can't be 1. And so what that means is that square is actually going to be either equal to 3 or greater than 3. Okay. And so let's see, and yeah, let's also, I guess, compare triangle and circle, and what do we get for C? That is also incorrect. So let's see. So we do have, I think we established that triangle is even and circle is even. Well, we know they're not equal because you can't have repeating digits. And if you notice, between triangle and square, I did pick a triangle that's smaller than circle. A triangle that's smaller than circle. 4 is less than 5. But again, the Turing machine does not agree with that. So in fact, triangle should be greater than circle. So let's go ahead and type that up in our notes. And that is that triangle is greater than circle. And let's see, can we cross out anything with that piece of information? If triangle is to be greater than circle. So yeah, I don't think circle can be a 5 because there's nothing bigger for triangle to be if circle is 5. As well as it can't be a 4 because again, even if circle is 4, there's nothing bigger for triangle to be. It can't be equal. Got to be greater. So that means we can cross out both 4 and 5. Well, that means that because we've sort of deduced that circle is the even, well, it's got to be the 2. Okay, so that really has opened up, or sort of helped us eliminate possibilities. So we know circle's 2, which means triangle has to be 4. Remember, no repeating digits. Okay, and so let's take a look at the square. We still have square to be 3, equal to 3 or greater than 3, but we also, let's see, we can't have a sum that's less than 6 because of 4, that's already going to be greater. And oh wow, do we really have to go to a third round? Because how do we distinguish between 3 and 5? It could either equal it or not. Well, let's update our notes here to say that the sum is going to be greater because 4 plus 3 and 4 plus 5 are both greater than 6. Okay. Triangle is greater than circle. Okay. That's very interesting for those two evens to be sorted that way, but yeah, I guess it makes sense. And yeah, we just can't guess between 3 and 5. I mean, obviously 5 would definitely be more helpful to get a sum that's greater than 6, but that may not be the case. Yeah, we're just going to have to test just to be sure. So I'm going to go with 432 as my third proposal. And again, all we're going to do is test criteria card A. Wow, so no, it's not equal to 3. Okay. So let's go ahead and cross this out. And so it's not a 3. So it looks like our solution is 452. Interesting. Okay, let's type it up. So 452. And so let's just quickly review. So yeah, obviously, we can conclusively prove that square has to be greater than 3, and it is. Triangle is an even digit, it is. Triangle is greater than circle, the first is greater than the third, it is. The overall sum is odd, yeah, 9 plus 2 is 11. And the sum of the first two is greater than 6, it is, that's 9. And there are no repetitions. So it looks great. Let's just confirm that 452 is our solution. So 452, fantastic. Now how do we do against the Turing machine? I am curious. Even though it is a 6 criteria puzzle, we did solve it with 7 questions in 3 rounds. That's cutting it close, but we'll see. The other thing I noticed is I only had 1 correct answer to a question, and that was F. Everything else was wrong, but yet we still were able to get a good, correct solution. So let's see. The first thing we tested was BDF, and then the second round we tested everything else, and then we retested A. And again, the only thing that we got correct was F. Very interesting. So BDF. Let's go type it up. So BDF was correct. Everything, my second round proposal was all wrong. And then we even got this incorrect for the third round. So let's see, how do we do? Wow, okay, we still beat it by 1 question. Fantastic. Well, like I mentioned, even if you get incorrect information, that's not all bad, because you're basically limiting or you're excluding all the incorrect pathways to find the solution. As long as you don't make the same mistake twice, you should be good. So all this information is just guiding us towards the right answer. Well, what do you think? How did you solve it? Did you see any inefficiencies on my part? Could I have made certain deductions earlier on? Add those ideas and thoughts to the comments. And if you like the video, do give it a thumbs up so that more people can find the channel. And of course, subscribe to not miss out on any future videos. Well, until next time, have a great one.